And I am going to switch this to present the what's on the screen instead of presenting a picture of me. All right, so if I go to, where is that screen share button? There we go. Screen share. Okay. Oops. So the Gmail account that I'm using to publish these for later reference is all right. Well, actually, I won't write that down. I'll just type it. Is it's ghy.gis@gmail.com. In fact, I have that on the course website. Oh, maybe we start with that. So the course website for this course, I put it on a site that's actually designed for submitting computer code. And it's called GitHub. And if you go to this URL, github.com/mapawesome, MAPOSSUM. That's my username on this site, my individual username, /SPA. And that'll be the place where I'll put most of the information for this course. We'll be writing computer code in this course. That's one thing that this course is about. And this is a website that's actually designed for sharing computer code. And so most of the lecture content will be computer code. And so I thought this would be a good place to store that. Now, it's also a place where you could store textual information. And so I put things like the syllabus here. If we scroll down, we'll see the syllabus. We'll go over that first, and then we'll start getting into things. All right, so that email address there is on this page. The one that I just referenced, it's right here. Okay, so that email address, oh, I messed up. That's actually not the right email address. So it's ghy.git, and I'll fix that. In fact, I can fix that. I'll fix it so that there's no questions here. So here we go. This is the one to turn email assignments into. So if I type in GIS, not GIT, and then I can just say fix email address, commit it, and the screen is too big. How do I make it smaller? Hold on. I don't know how to make that individual page smaller except for to unplug that for a second. The big, I'll sync it and then plug it back in here. Okay. All right. So if we go back to the course website here and refresh the page, now that's the correct address. All right. So ghy.gis@gmail.com. That is the Gmail address that I'm using to store these presentations on. So if you add that to your circle in Gmail, or you could just search for that, you'll get that. In addition, so that's optional. You don't have to do that. That's just so you have the archived lectures if you want them. And then but this is the address where you turn assignments into. Okay, so you turn assignments into that address, ghy.gis@gmail.com. The top information we all know when the class meets. Technically, together, the lecture and the lab is a 4-hour course. So technically, we'll meet for just under 4 hours, because it's really when 4 hours means 4 50-minute periods on Tuesdays. So we'll get out of here probably. It's hard to talk for 4 hours. I'll probably get out of here at 8:30 or so every week, except for this week. This week's not going to go that long. All right, here's my contact information. If you have a regular question, please email to my USM address. That's the one I check more often. I don't check that ghy.gis one as much. So that's one for grading. Please visit that website. And please send assignments to there, regular questions to my other address. Okay, for my office hours there, I'll be around for sure Tuesdays. I teach Tuesdays. I'll also be around Wednesday morning. That may change to Monday morning, but I'll be around on 2 days for sure. I'm also available at other times if you want to make an appointment with me. Okay. All right. So what's this course about? I've told you that we're going to learn how to do computer programming. We're going to write code in this course, and that's true. That's what we're going to do. Why are we going to write code, and why are we talking about it in a GIS course? Well, there are actually a lot of tasks that can be completed using programming that are difficult or very tedious to do without any computer programming. One of the big things, and actually the technical title of this course is Spatial Programming and Automation. One of the big things that we can do is to do similar things multiple times. I don't know if in your experience with GIS, if you've ever wanted to do something over and over again. Maybe it was actually a lab assignment where somebody said, okay, you need to do this almost same thing to 7 data sets, or you need to do the same thing to 10 data sets while only slightly changing one parameter. Okay. Well, it'd be nice not to have to press all the buttons over and over and over again, particularly if it's a very similar task where you're just changing one thing. Okay. Well, that's one thing that can be shortened through programming, is to automate repetitive tasks. Okay, that's what we mean by automation. Another big thing is, what if we want to combine GIS with some other program that somebody's created? And lots of times, the glue for merging those two programs is done by programming, through telling the computer instructions. Okay. Computers are very complex, and really the topic of programming is huge. I mean, people major in computer science, and that is not one of the goals of the course. Okay. We're going to limit our programming to a specific type of program that's often referred to as scripting. Okay. Scripting is writing computer programs in languages that are higher level. Okay, they're not down into the ones and zeros. We still have to learn a little bit about how computers talk to each other and how computers talk to us in order to do what we want to do. Okay. So also another thing that we might want to be able to do is to customize the way a GIS operation works, to change a GIS operation, and that's another thing. So we've got automation, coupling, and customizations. So this course, it focuses on the extension of GIS. So we're specifically going to look at GIS through programming, and that's going to involve customization and some algorithm development. You can read through that information on your own. Okay. So having said that, I forgot to put in. Well, I did. I put it up here and I put it down here. I did. I probably should have put this up above there. Having said all this, you might be thinking, what are the prerequisites for this course? Now, if you're a geography undergraduate, one of the requirements. Sorry, not geography, a GIT undergraduate, one of the requirements is that you take a computer programming course over in the computer science department. It would be very helpful if you took that course before taking this course, or at least take them together. Okay? If you haven't taken that course yet and you're not taking it this semester, you could still do it. We don't require that as a prerequisite, but we encourage you to do that, because lots of the concepts you learn in that course will help you here. What is a requirement is that you have some GIS background, because we don't want to spend a whole lot of time explaining GIS concepts. So you should have taken an introductory course in GIS, which now we number 217. We actually aren't going to be using a whole lot of GIS for the first couple weeks. So if you haven't taken GIS and you're really gung-ho student, you can come talk to me, and we can try to provide some materials that will help you to acquire that knowledge. Okay, but if you have time and you're going to be here for a while, I'd recommend taking one of those courses beforehand. Okay, so this is a typical lecture lab assignment. I've got to change the URL there again. I'm sorry, the email address there again as well. Sorry, I'll change that later. Won't do that again. But that's this course used to be called Computer Applications in Geography. That's why the CAG. But I just got rid of that and used that .gis email. Okay. So what are you going to be expected to do in this course? Well, every week you'll have a lab assignment. Today's lab assignment, you're still going to have an assignment today, but it's actually not going to be one that you turn in. So every week I'll have a lab assignment, and that'll consist of writing a computer program. Okay? They'll start off fairly small, and they'll get bigger. They won't ever get huge. Like, you're not going to be responsible for, writing a computer program that comes up with a new way to do GIS analysis, unless there's a small way to do it. So they're going to be small assignments, but you're still going to have to spend time outside of class learning and trying to figure it out and working with me. We don't have a lab instructor for this course, so I'll be doing the lab instructor, but you'll have to spend time outside of class, and it is a 4-hour college course, so it might take you some time to complete the assignments. In addition to that, everybody is going to be responsible for creating a GIS program that automates a task. So, you can decide what that is. And the program, maybe I shouldn't go over all the requirements here because we haven't learned these terms yet, but you have to implement a few things: branching, looping. The undergraduates are going to be responsible for turning in a short summary of what their tool does. The graduate students are going to be responsible for turning in a paper. Okay. That's going to be due May 1st. Since this is considered a night class, there's no final exam time given. We're supposed to hold the final exam on the last day of class, which is the 28th of April. So that's actually after the final exam period. I haven't decided, but I'm pretty sure that I'm actually, instead of having a formal final, the final would just be another little project that I'll give you to work on. That won't be true of the midterm. The midterm will still be a traditional exam that you'll take, just so that I can kind of get an idea of where you are in terms of what we've been working on up to that point. All right. So the required materials. Good news, you do not have to purchase a book for this course. I have a number of free materials that I've gathered together along with the lecture notes for the course that you can rely on. So there's a link to the book that we're going to use for the course, and we're not going to use all the book. We're going to use like 70% of the book, but it's free, so it doesn't matter. You can link that. There's an HTML version and a PDF version. When I refer to a page number, I'm going to be referring to the PDF version of this book. And the newest version came out in 2014, but again, that's a free book. If you want to print off a copy, you can. I find that it's actually easier not to work from a printed copy. You keep it up in a web browser and copy what you need right from that into the code windows, rather than having a printed copy, because you can't copy and paste from that. Will also be the computer programming languages we're going to use is called Python. There's some documentation online for that. There's a link to a Google Python course. Also, since we're going to be using this a lot as part of ArcGIS, there's lots of documentation on how to do things in Python within ArcGIS, and I'll show you how to get and access that as well. So what you need for the course is, in terms of software, is ArcGIS 10.x, and I forgot to bring my copies, but I noticed that many of you should already have a copy. So you'll need a copy of ArcGIS 10, which is installed on all of these computers. And part of installing ArcGIS 10 is installing this programming language that we're going to use. Okay, it's called Python. It comes with ArcGIS 10. Okay. But you should know that they're actually two separate packages. Okay, ArcGIS 10 is a commercial software package developed by a company called ESRI, and Python is an open source, freely available computer programming language. So they're separate, and ArcGIS packages up Python, and Python is popular in lots of programming circles. It's not just for ArcGIS. So one of the great things is that you'll be able to, and you'll see this as the course progresses, you'll be able to use this knowledge and apply it in other areas. You could download and install it for free, but I should have had I had a second statement, and I don't know what happened to it. Maybe I didn't press save on my desktop. But if you've already installed ArcGIS 10, you had to have installed Python. So if you installed one, you installed the other, and that's probably the better way to do it. Even though we won't be using ArcGIS part for a week or two, it's best to just install, 2 or 3 weeks. It's best to just install ArcGIS. Is there anybody here that needs a copy of ArcGIS? We'll get it in my office after class. It's installed in all these things. Here's the grading policy. I won't read through all that. Does somebody have a question there? Sorry.
Yes, I'm sorry. I didn't mean to interrupt.
No problem. Go ahead. You need a copy?
Yes, please. Okay.
I will. I'll have to send that down through campus mail, and that's Daryl that's talking.
Yes.
Okay. I'll send it down through campus mail. If you want to ask, I'll send it down today. Well, it probably won't get in the mail until tomorrow. If you want to ask David Holt, if you see him, if he has a copy, you might get it sooner than campus mail. But it'll. Yeah, go ahead.
Okay. I'll just check with him.
Okay. Well, I'll send it down just so you have the copy on hand. When you talk, it's don't feel like you're interrupting me. There's like a second lag, so you may start talking when I pause, but I may have already started up, and don't feel bad about that. So you don't have to apologize for interrupting me. I understand. It's the lag. It's not that you're just talking over me. So feel free to ask a question whenever you have one. All right. So this is the schedule. Again, we can go over. I mean, that's actually, as we go throughout the course, you can read that. These are kind of the different topics we're going to cover. Remember, the last time we're meeting, including for a final exam for this course, is the 28th, where we'll have final project presentations. And if we do have a traditional final, it'll be on that day. But I'm picturing more like we'll have an assignment. I may be able to actually give that even before that date. Okay, so that's the syllabus. Now, if you look on the course page, if you click into week 1, you'll notice that there's also a file that goes over the content of the lecture, and there'll be that one for every week. So for week 2, it'll be the same. And as I go over the content for that week, I'll be writing little computer programs with little examples. And what I'll do is save that information and then post it onto this website. Okay? So that information will be there, and you'll be able to download those little code examples that I create, or maybe sometimes big code examples that I create, and work from those. Okay. All right. If you ever wanted to just download the entire website, you can do that as well. All the content. You might have to be logged in. Nope, you don't. If you go to the root, outside of week 1, and you just hit download zip, it'll download everything for everything that's on the website. It'll create your own little thing. Also, if you were to install, there's a program called GitHub that you can install that'll allow you to post your own, create your own sites. I'm not going to let you edit this site just because that would get kind of crazy and you might mess it up by adding. So, but anyway, you could also clone the whole site and then ask for updates. Maybe we can discuss that at a later time, but we'll wait until that makes more sense. But both of these buttons will allow you to download the whole thing. If you don't want the whole thing, you can just click into it and then you just cut and paste it. Okay, so most of this will be code. It'll work to just cut and paste it. Okay. All right, so that's the course. I'm actually going to close this up. These are the topics that we're going to talk about, but I'm not going to use slides in this course, okay? Because it's a programming course, so we're gonna actually talk about code and demonstrate code rather than using slides. So this is the lecture notes that I'm going to work from, but I'm not going to leave that up while I talk. So I'm going to go ahead and minimize this and get into I don't need that either. Oops. Okay. So the first thing that I want to show you here is, let's open up ArcGIS. Okay. And again, I said we wouldn't be using ArcGIS. Well, this is the exception. We're gonna show something in ArcGIS. So this is ArcGIS. It's a program for doing GIS. We've all used it, or you should have all used ArcGIS beforehand. ArcGIS actually has Python built right into it. So you can go open up this little window, and it gives you a Python prompt. Okay? Python is a programming language. Okay? It's an example of what we call a high-level programming language. What that means, and I used that term already once, but what that means is that it's more similar to a natural language that you and I would use to talk to each other than a low-level language that a computer actually needs to be talked to in, like basically ones and zeros. Most languages that people learn and say, hey, I can program in are high-level languages. Some other examples of high-level languages are C, C++, Perl, and Java. And some people would even argue that those different languages have different levels of how high-level they are. Okay? Python is very high-level. We're gonna deal with things. We're gonna talk about how we can deal with things as objects and as entities. Okay? Things that computers inherently by themselves wouldn't understand, but we build those from a foundation, so we have those to work with. Okay? Python works through an interpreter, and not all computer languages work through an interpreter. When we submit commands to Python, or statements, that's probably better to say, when we say something in Python, we can tell Python to execute that statement right away. We say things in English in our natural language using statements. We'll say things to Python using statements. Okay? And some of those statements are very similar to English language statements. Like we might say we might say 5 plus 7. Okay? 5 plus 7, we all know what that statement is. Lots of mathematical statements are very similar in Python than they are to the English language. So we all know that 5 plus 7 is 12, and it's given us that answer. Okay, so this is what we call, sorry, this right here is what we call the prompt, the Python prompt. Okay. So we can tell the Python interpreter, or we can tell the Python interpreter statements, and it will return the result of those statements to the screen. Now, what's going on in the background? Well, in the background, it takes 5 plus 7, and just like you and I when we talk, it parses that statement. Okay, it turns it into its individual elements, and then as an interpreted language, it has to take the interpretation of what it got, and then it has to turn it into machine code, and then take the machine code and execute the machine code, get the result, and then return it back to you. So the interpreter does all that at the same time. It's a little different to some computer programs. Some computer programs, when you write the computer program, you compile that computer program, and what happens during the compilation process is that computer program turns from your statements and text, it turns it into code that the computer can understand. And one example of that is, who knows what a .exe file does? It's just an executable, right? An executable file. In fact, if you looked on disk, ArcMap itself is an executable. And so the compiler turns the program that you wrote into an exe, into an executable. And that executable can be run on any machine that understands that particular basic language. They don't need to have a copy of the compiler. However, Python doesn't work that way. When we write Python, it stays as our statements. And any computer that we execute Python on has to have a Python interpreter on that machine. Okay. So if you don't have Python installed, the computer will say, I don't know what you're talking about. Now, right now, most Linux distributions and the Mac operating system come with Python installed by default. Windows isn't like that, but as ArcGIS, with ArcGIS, it comes installed with ArcGIS, so we get it. All right. So when we run Python in this way, where we just type a statement, 7 times 9 is another statement, and it's 63. Now that looks a little bit different because we used a different symbol there. Okay, why couldn't we type in 7x9? That looks a little bit more like what we learned in 3rd grade, right? Type that, and it tells us there's a syntax error. Okay? In other words, it had a problem parsing that. It says parsing error, invalid syntax. Okay? So whenever we give a statement to Python, it has to be able to be understood by that language. And 7x9, it just interprets that as an invalid statement. Okay, we've got a 7, we've got a 9, and we've got an x, but it didn't know what to do because those aren't valid in that order. Now, those are all valid Python things. For example, we could say x equals 9. That's valid for some reason. We don't know what the reason is yet, but we'll get to that in just a second. That works. We can say now we could say x plus 9 actually, and it'll tell us that it's 18. Okay. Let's kind of see what's going on here. We've taken 9 and we've made x equal to 9. So x is 9 now. Then we take x and we add 9 and we get 18. So that's 9 plus 9 is 18. So so those are examples of some statements. All right. Every program that we're going to write, sorry, one more thing. So this is interactive mode. And in ArcGIS, we only have the ability to interact with Python in interactive mode. Okay? But it is there. And it'll become useful in a few weeks where we might just want to run a quick Python snippet in ArcGIS to interact with some data layers. Okay? But for now, we're going to put interacting with data layers aside, and we're going to open up Python in a different way. If you go to, and it'll be slightly different on your computer than mine. If you go to Programs, you should have one called Python. Do you see it? Oh, it's probably under ArcGIS, sorry. Python, ArcGIS, and sorry. Oh, Programs, ArcGIS, Python. And it might say Python 2.7 or it might say Python 2.8, depending on which version of ArcGIS you're using. Okay, so if you open up that window, you'll see a few other programs. The very first one is IDLE. By the way, you should be doing this along with me this time. Okay, so if you see that program called IDLE, open that up. Does anybody have an issue opening that? Everybody got that open on the coast? You got IDLE open? Everybody here? What's that?
Working on it.
Working on it. Okay. Let me know when you get that up. So it should be under ArcGIS, and then Python, and then IDLE. Everybody here got it open? Okay, great. How about on the coast? Okay. All right. So we've all got it open, and it looks very similar. At least the prompt looks very similar here than it did in ArcGIS. So we've got the ability to do the same kinds of things. 6 plus 7, we get 13. Okay. All right. This is interactive mode. The other mode, because this would get pretty boring to have to, or tedious to have to enter in our programs every time we wanted to run them line by line. Okay. The other way is to say File. Under File, we can go New Window, and we can create our own program. And we can write as much as we want. Okay, we can write our program right in here. And so if I did the same thing, I said 6 plus 7. By the way, before you run it, you have to save it. So I'm going to save this in the directory that I've been working with. You could save it wherever you want, but this is so that I'll be able to post it to the course website. So if I call this example 1.py, putting .py is optional. This is just a text file. In other words, this is a file that contains nothing but text. There's no special information in this file. But if you put the extension .py, the interpreter, or not the interpreter, the window here will know that it's a Python file and will help you out by highlighting and showing you some things that it wouldn't do if you didn't call it .py. So name it .py. The other thing is, if you ever double click it, it'll run it if you name it .py. If you don't name it .py, it's not a big deal, but it might confuse you later. So I would always name it .py. So this is my example 1.py. All right. So if I hit run here, I run my module, it doesn't seem like anything happened. It started up, and it basically printed 3 lines on the page. Okay. The reason why nothing happened is because my computer program doesn't do anything. It just tells the computer to add 6 and 7 and then stop. I mean, it gets to the end of the script and it stops. So it starts at the beginning of the script or the program, runs through, gets to the end and stops. So I'm missing some things, okay? I'm missing a few things that are important. And this is from your book here. All computer programs should have input. They should have output. They're all going to have some math, some conditional expressions. They might even involve some repetition. Okay? So that's what a computer program is. And basically, we can boil that down. So your book has all those things listed. We can boil it down to input and output with some things in the middle. Okay, so we've got our input, we've got our output, we've got our things in the middle. Now, when I go to press, when I run it, and it'll interpret it just as it did at the window. So if I enter in a statement that was not valid, it will give me an error. So if I did something like, say something like x plus 7 and tried to run that, it's going to ask me if I want to save it. It's going to give me an error. Now this error is a little bit different. It's not a syntax error like we had before. And so we'll get to those type of errors later. So let me change this so that it actually makes it a syntax error. 9 times 7 the wrong way will give me an error. So it will report an error. In fact, it won't even try to do it because it's part of the interpret. As part of the why did I go blank all of a sudden? As part of the interpreting our code, it can't even turn it into to computer code. It can't take our Python statement and turn it into computer code. So that's a syntax error. In fact, most times when you make a syntax error, it won't even try to run it. It'll just do something like this. It'll highlight it and tell you, oh, you made an error. I don't even know what you're trying to say. Okay. So if you get an error like this, you've made a Python mistake. You're trying to talk Python, but you're failing basically. You're not communicating Python to the interpreter. So this is saying this is invalid Python. It'd be like if I said, in English, I apple. Okay, I apple. Okay, that doesn't mean anything in English. I mean, you might be able to think, is that guy saying he's an apple, or is he saying he wants an apple, or is he saying he ate an apple? And what's he trying to say? It's missing something, right? It's missing the verb. And so you wouldn't be able to act on his statement unless you had some other way of communicating. So this is the equivalent in Python, is a syntax error where the structure is wrong. Now the other one that I said, x plus 7, I tried to run that and I get an error. It says x is not defined. That's actually referred to as a runtime error. It's perfectly good Python. It's just that once the computer tried to run it, it realized that it didn't have all the information to run that. So that'd be like if you said to somebody, can you give Bob $5? Okay. The computer program is saying, I have no idea who Bob is. Okay. I don't know Bob. So no, I can't give Bob $5. You have to tell me who Bob is first, unless I already know who Bob is. Okay, so that's the equivalent. That's a runtime error. Runtime error, sometimes they're referred to as exceptions. And finally, there's what we call semantic errors, which sometimes I just like to refer to those as your program works, it just doesn't work like you think it should work. So that might happen if you just enter the wrong formula for something. Okay, these are the hardest errors to overcome because your program runs and it says it produces an output. It might even produce an output, but the number is not correct. Okay, so that often involves somebody figuring out that your program's not producing the right solution. All right. One of the nice things about Python, and actually computer programming wasn't always this way, is that we have the luxury of writing our programs as short, bursts of code, running them, and unless they take a long time to process, we instantly get feedback. That's really nice. My dad was an economics major, and he actually went to work in the computer lab down there. because he got interested in computers. Because they were starting to write programs in their economics course, and they actually had to take, you know, they had to write a program, then they'd have to have the program print out a bunch of cards that had like holes in them. Basically, that was the process that we call the interpreter today. It turned it into bytecode for the computer. So they take the stack of cards to a whole different building where the big computer was, and then the big computer would read all their cards. And if they wrote something like, you know, 9x7, they would get an error. Then they'd have to go do that whole process again. It's nice to just be able to hit run and get instant feedback and know why we have that. And so sometimes they refer to that process now as experimental debugging. We can write code, and if it's bad code, the computer instantly tells us back. All right, the next thing your book talks about is this difference between a natural language and a formal language, and I've already kind of discussed that. So Python is a formal language. Natural languages are the languages that we speak, and they are different. Okay, natural languages are ambiguous. Okay? Like I can say, I walked up that mountain, or I hiked up that mountain, and it means almost the same thing. A hike might include, or might imply that it was a longer trip or something like that. But there's often more than one way to say things, and when I do say things, they can be said in slightly different ways. Also, because our brains are good at it, sometimes if somebody doesn't say things quite right, we can still understand their meaning. But formal languages aren't like that. Okay? Formal languages, they are a lot more like math. Math is actually, in some ways, in fact, a lot of people would say, a formal language. Okay? It's a language for expressing things that are numerical. So as an extension of that, a formal language for programming will include those mathematical ways to express things, but we'll also have ways to write programs. Writing a program is nothing more than giving a series of instructions to a computer. Okay. All right, so we already used the word parsing. Okay. Parsing is that process of breaking apart a formal language and starting to interpret it. Now, going back even before that, we have a concept called tokens. Tokens are the basic elements of a language. So in a natural language, those are the words, the punctuation, all that stuff. Okay. In a formal languages, it's the same thing. It's the symbols that we're using. Okay. So if I look back at this script here, where I did the x for the 9x x7, okay, and when I tried to run that and I got the error, the problem is that all of those are valid tokens. Okay, those are things we've seen x work in another place, but the structure is wrong. Okay, so those are all valid. Those are all valid tokens, but the structure is wrong. When I did this, when I said x equals 7, okay, and that didn't work. Remember, it said that it didn't know what x was. What it was saying there was I didn't know what the value of x was in that case. So those are all tokens. Let me go ahead and take this off real quick. Sorry, getting more. Okay. So that's the process. So there's very little ambiguity in formal languages like Python. So lots of times when we see an error, it's just a matter of us tweaking it until we can get that in the literal way that it needs to be. Okay. All right. So we've kind of written a program, but let's go ahead and write our first program. Oftentimes in computer science, the very first program that we're going to run is called the Hello World program. So we're going to print Hello World. So we've got that program. What do you think this program is going to do? It's not rocket science. Nobody has any thoughts? It's gonna print hello world. Okay, so I ran it, and it in fact printed hello world. It printed the words hello world onto the screen. Okay. So one thing that I forgot to mention earlier, I was going to mention it earlier, but the book just brings it up right now, is that there's actually a few different versions of Python. There's lots of different versions of Python. They continually upgrade. So Python started, way back version 0.1, grew up and grew up and grew up. Well, when they released version 2, the very next version that they released, they decided to make it so that it had a few of Python's quirks were taken out of it. Okay? And what that did was it actually broke Python backward compatibility. In other words, you could write code in Python 3 that wasn't valid in Python 2, wasn't valid code. Okay? The tokens were slightly different. So we're going to be using Python 2 for this course because most people are still writing programs that are backward compatible. We're kind of in an awkward Python stage right now. The differences between Python 2 and Python 3 aren't that great, but they're just big enough that they cause some issues. And so, maybe 10 years down the road, maybe it'll come sooner than that. People will totally abandon Python 2, but there's so much existing code. ArcGIS still uses Python 2. So, until big companies start using the new stuff, there's still plenty to be had. There's there's actually not lots of differences. There's a few little differences, and one of them is how they write code. And this will probably be the last time I really mention it, but in Python 3, the same statement would be like this. That's actually one of the biggest differences. What's interesting is that in Python 2, they slowly started adding some of these changes. So maybe they'll just merge at some point. I don't know. I don't write computer programming languages. I just know a few of those languages. So we had those two differences, right? Print hello world does the exact same thing as print with parentheses hello world. This doesn't make a whole lot of sense right now as to why those are different. However, after next week, I think that everybody will agree that this one actually makes more sense, and that's one reason why they changed it. Okay? It's not the only difference, but it's one of the only differences in terms of Python 2 and Python 3. Okay. All right. So that was our first program. We wrote print hello world. It ran. Run it again, and it prints hello world. All right. Now we've already used this, but the next thing that we're going to learn about are called our values and types. Okay. All right. In a computer. Computers store information, right? Every piece of information, I guess we could start calling it that. Every piece of information that's stored in the computer, we're going to refer to that as a value. A value is a piece of information stored in a computer. It could be a letter, it could be a number, it could even be a whole series of letters or a whole series of numbers. It's a value. A value is a piece of information stored on the computer that we're going to interact with. Okay. In our example here, hello world was a series of information stored on a computer, a series of letters stored on a computer. So all values in a computer, all these values, basically stored information on the computer, they all have to have a type. Every value has a type. Okay. So in this case, hello world had a type. In fact, I'm going to retype hello world, and I'm going to wrap it in this statement here. I'm going to press enter, and it's going to tell me the type of that value, the type of hello world. Hello world is a string. Okay? That's what that means. It says str, but it means it's a string. I could do the same thing with another set of information. I'll go with 4. So the type of 4 is an integer. Okay. INT means integer. There are all sorts of different data types, but one more type that we'll introduce here. Type of 5.6. Float. Okay. This is float. What that means is it's a number that has a decimal point after it. Okay. Now, I'm going to tell you, in many computer programming languages, when you create a new value, before you create that value, you have to tell the computer what type of value you're creating. In Python, you don't have to do that. That's a difference between Python and other languages. Okay? Some languages, they call them strongly typed languages, they require you to declare, I am creating a value, and this value will be a string. Okay? Then once you declare that you're creating a value and it's going to be a string, then you can start working with that value. Okay? Python doesn't do that. It's one of the ways that Python is a simple language. Okay? But there's going to be a few tricks to that, but we'll get over it. For example, like what if I added a string and a float? So like, what if I do 5 plus 5.5 or 5.5 here? Okay, I'm going to get 10.5, which is what you expect, right? Okay. So Python takes care of reconciling things that aren't some things. But what if I did 5 plus hello world? What do you think it's going to do there? Give me an error. Okay, it can't add. It's saying that my interpreter doesn't allow me to combine those two data types. I don't have a plus operator. We haven't used that word yet, but we'll use it in a second. I haven't used that plus operator to combine 5 and 7. 5 and 7, I mean 5 and hello world, sorry, not 5 and 7. 5 and hello world, they don't combine using the plus operator. 5.5 and 5, even though one's a string, one's a floating point number and one's an integer, I can still add those. That's cool, I understand. In its brain, it's actually converting that 5 into 5.0 and then adding them together. Okay? That's one reason why we say Python is a very high level language. Many other languages would actually produce an error if you tried to add an integer and a float unless you change the type. You can change the type, you can do that, but unless you actually explicitly said this is a float 5, so it's really 5.0. Okay. All right. Okay. So that's that. Can't add things like that. All right. Okay. So we talked about values. Okay. Values are pieces of information on the computer that we can interact with. Okay. Taking that one more step further in the programming world, a variable is a name that we assign to that value. We give it a name. So I can take any value and give it a name, and what I'm doing when I do that is the computer, sorry, not what I'm doing, but what the computer does is it attaches the name that you give it to a specific piece of memory in the computer somewhere. So those get put together. So the way that we do that is do something like, I could say, n equals 30 or 36. Okay, n is often used as in mathematical notation to mean the count, the number of times something happens. So I'm just saying n is equal to 35. Now, when this computer program runs, it'll take that value 36 and it'll take care of 36 is going to go in a particular part of memory, and as long as you call it n, you're going to be able to get it to it. So if I did something like print n, I ran this, going to print 36 because it's going to get that value out of the box that's called in. So it's creating a specific box or an area in memory, in the computer's memory, and it's putting it in there, and when I ask it to print it, it goes and gets that value and gives it back to you. Actually, I should say it just tells you what's there. Okay? It doesn't give it back to you physically, because what if I wrote print n again? It would print 36 once again. So it's still there. It's just going back and checking on that value again. Okay. All right. We can store float. We can store strings. We can store all sorts of things. As we get further down the road, we'll be able to store things like data layers, entire data layers. But everything is built up from these primary data types, strings and numbers. There's a few different types of numbers, but everything's built up from those. Okay. All right. So there's a few other examples in there, but so be able to work through there. All right. For variables, we can actually name our variables almost anything we want. There are a few bad things. We can't name a variable. We can't make a variable start with a number. Okay, see that? What I wrote there, I wrote 4O equals 9. I could write O equals 9. I wouldn't suggest using O as a variable name. Why? Because it looks like a 0. But there's nothing illegal about it. You can do that. So O is equal to 9. If I print O, I'll get 9. Okay. But variable names can't start with numbers. Variable names also can't be on a list of reserved words. And I won't go over the list of reserved words here. It's in your book. But you can see that print would probably be one of them, right? Print equals 0. It's going to tell us you can't do that. Print does not equal 0 because print is a special word. There's a few examples, like and is one, except, break. There's a list of them. There's a few additional keywords in Python 3, but that's not really important. Okay. Oh, also no special characters in there, so you can't say and t and t equals 5 equals 9. Okay, you can't do that. So no special characters, only text. The other thing is that not all programming languages are case sensitive. What do I mean by case sensitive? That means uppercase, lowercase. So if I say t equals 9, and then I say print big T, I'll get an error. Python is case sensitive. So that'll get you, okay, as you start to write your own programs, you might get an error that says your variable that you made up is not defined, whatever your variable is. In my case, it's T. You might say, I know I defined it. Well, if you named it something that was different, then you're going to get, it's not going to be, it needs to be exactly the same. Okay? I like to name my variables things that make sense, but I don't always do that. Sometimes that's easier to do in practice. So sometimes my variables, I start calling them thing and thing 1 and thing 2 and then thing 3. And it's like a Dr. Seuss book after a while. You should name them things that make sense. Like you could say, later if it's a data layer, you could say strings layer. That might be the name of your variable. All right. That makes the code more readable, easier for people to understand. All right. Also, they get overwritten. So if I do something like t equals 9, and I say print t, and if I say t equals 0, and then I say print t, t has become 0. Okay. It actually, that time it did go to that box. It threw the 9 out, meaning that it just got rid of it. It's taking that exact, in the computer's memory, that's just a row of 1s and 0s, okay? And so it flipped all the switches that represented a 9 and changed them into a 0 for you. So every time you go back and ask what's in that box, it's going to say, well, there's a 0 in the box now. So it basically got rid of it. So that's another thing that you need to watch out for. If you name a variable something and then later you name a different variable the same thing, it's going to overwrite that variable. So you'll get issues with that. Okay, now we've used these already, but this thing in the middle, when we do things like 7 times 7, that thing in the middle is called a operator. Okay, we're doing an operator. So that thing in the middle, 7 times 7 is an operator. The values, these things, 7 and 7 are called the operands. They're being operated on. Okay, but this is the operator in the middle. And there's lots of different operators, but most of the ones that we'll need for this course are just your basic mathematical operators. There's add, subtract, multiply, and divide. And the only one that's really maybe tricky is the multiply. So if we want to do divide, it's 7 divided by 7, like that, you might expect. The slash, and the direction of the slash does matter in this case. Okay? 7 divided by 7 equals 1. Interestingly, let's make sure that 7 divided by 6.5, what does that equal? Okay, that equals 1.07. That wasn't always true in Python. Okay, as Python has progressed, it's decided that this is the way to go. It used to be that if any of your operators were integers, the result would be an integer. So sometimes I'm still paranoid, and I'll explicitly convert that 7 into a floating point number, okay, which we'll talk about later, but that'll work. So you've got different operators. There's one. We can even do. So the one other example in your book is 5, 2. Okay. Does anybody know what that did based on the result? Yeah, it squared it. So a double asterisk there means to do the exponent. So 5 to the second power. Okay. Obviously, we could just say 5 times 5 would be the same thing. So sometimes, just like with any math, there's more than one way to do it. Now, you can put spaces between operands, but you don't have to. So that's another quirk with Python. I always like to put spaces in between mine, but that's just a matter of opinion. Okay? So I can do 5 plus 7, or I can do 5 plus 7. There are places where spaces matter, but in between operators and operands is not one of those locations. Spaces don't matter there. Okay. So we would call this, 5 plus 7, or even if we go back over here to our example, we would call this a statement. That's a statement. Okay. In Python, every statement has to be a new line of code. In some other programming languages, statements can be delimited by some other character. Okay. For example, in Java, we put a little guy like that, a semicolon. That's what that's called, right? Semicolon. And then we could type a new statement. We could say y equals 8 on the same line, okay? And it would be just fine. Python, we can't do that. There's no line delimiter. So every expression is on a new line of code, or every statement. Sorry, every statement is a new line of code. Okay. Yeah, I've used those terms, expression and statement, interchangeably. Technically, they are interchangeably, as the book says, but sometimes it's important to think of them separately. An expression has a value, a statement does not. All right. Okay, we've already covered interactive and script mode. Just remember, just like math, there is an order of operations. Okay. So, if I said 5 plus 7 minus, or that's an okay example, but so what's going to happen if I say, okay, I'm going to say n and equals here 5 minus 7 plus 9 or times 9. I run that. Okay, I'm going to get negative 58. The reason why I get negative 58 is because of the order of operations. We all know, or we should have learned back in math class, that 7 times 9 is done first. Then that number, 5 is subtracted from that number. So we get a very large negative number because we get 5. What's 7 times 9? You know, 60. What? 7 times 9, 63. We get 63. Take 5 minus 63, and we get the answer that we got on that other page, negative 58. Okay. All right. Okay. There are some you think before we had that example where we said hello plus, we had that example where we tried to add it to 5. What if we did this, or we tried to take one string and add it to another string? Well, that actually is valid. It's going to take those two strings and push them together. Okay. So there are a few other things. We can actually multiply things, I think. But we can't multiply. However, we can do this. We can actually multiply strings with numbers. So we got high. So again, it's not really important that you memorize all of these things that the strings can do, but there are ways to manipulate strings. So as you read through the book, you'll see a few other examples of things that strings can do, and that's very useful, particularly for formatting the output of whatever our program is going to do. Okay? We might want to print something over and over and over, and rather than writing it over and over and over in the program, we just could go high times 7, or like what happens if we wanted to make a very rudimentary histogram? Okay, and everybody know what a histogram is? It's like a count. So we wanted to count how many times something happened in 5 or 6 different examples. So we wrote a program that counted up how many times something was done. Could write a program that did that. Then when we went to output that, we could, and we'll talk about this later in the course, we could get a software package that was designed for symbolizing. But if we wanted a rudimentary version of that histogram, we could tell it to print for each example. We could tell it to print an asterisk that many times. So if there were 7 observations in that class, it would print out 7 of these guys. And if there were 20 of them, it would print out 20 of those guys. And so it would print all of those out on a piece of paper. So that might be an example of why. Right now, I'm just trying to give you an example of why we'd want to use this particular syntax. Okay. All right. Okay. What happens if we want to put something in our code that we don't want the interpreter to pay attention to? That's called a comment. Okay. If we put this little hash symbol or a pound sign, whatever you want to call it, if we put that before a line, then we can write whatever we want, literally whatever we want. It will ignore it. Okay, so it'll still run that program, even though this is not valid Python. It's valid English, except for I didn't put a period. But you don't need. It doesn't matter. It doesn't matter if it's valid English or what. That's how we write a comment. So comments are great. A few times when you write your code, I'm going to ask you to include comments. Okay? I'm going to ask you to tell me what something does. You can put it after or before. Anything after the pound sign is ignored. So I could put it right there and it would work just fine. Okay. See that? If I run it, it's still going to give me negative 58. All right. Okay. All right. Well, that is the first 2 chapters of the book, which is what I wanted to get through today. A few things that I'll tell you to kind of whet your appetite for next week and tell you what you should be paying attention to. I would like you to go ahead and read now the first 2 chapters and try to do all the exercises except for the one that I noted. There's one in there where it tells you to search up what the print statement does online, and the instructions that it gives you are no longer valid. Okay. Go ahead and do all the exercises. The exercises are all actually, they shouldn't be called exercises. They should be called questions that you can work on. You're not really writing computer programs yet. You're just kind of exploring. So go ahead and go through the first 2 chapters in the book and write those. Okay. And do those, not write them. You don't have to turn them in. Then go ahead and read for next week. And I've included the instructions here. If you go back to the README file, you're to read ahead chapters 3, 4, and 5 in the book. And as you're reading, it wouldn't be bad to attempt some of the exercises. Okay? That's something that you could do. We're going to actually assign some of those exercises for the class. Okay, so you do them, you'll learn. Okay, that's what I would recommend that you do. Is go through, read 3, 4, and 5, and next week we'll talk about those. One of the big things that we'll talk about next week is a function. And we've already used functions, whether you realize it or not, when we did things like ask for the type. Like if I go back here and I ask for the type, I say type of n. Now that n is defined, it's going to tell me it's an int. Okay. So what's happened is that a function is just like a mathematical function that you guys think about, right? We talk about functions, we write them, we say, y equals mx plus b. So that's a function where we can plug in m and x and b, and we get the result. Y will always be that. So a function is kind of like a miniature program. It runs some code. In this case, the code returns the value of that function. And this is actually why in Python 3 they decided to make this a function, because it does. I'll just write hello. It does in fact return something. It returns hello. So instead of making that purely a statement, they drive home the point that it's now a function. But we could write functions for finding the equation of a line. We could write functions for doing all sorts of things. They're the building blocks of a program. So function is like a miniature program in and of itself. So lots of times an actual program is made up of a few different functions. It doesn't have to be, but it makes it easier to program. So that's what we'll discuss next week. We'll talk about functions, calling functions, just to give you an example here, we all know that n, right, was an integer. One function takes an integer and it turns it into a float, and that's this function. So it converted it converted n, which had a value of -58. It converted it into a floating point number, -58.0. So that's what when I was saying that it's always helpful to make sure that your data is in the right your values are in the right data type. You can explicitly convert them by using this built-in function. So there's lots of built-in functions that are already included in Python, and there's you can write your own functions, and we'll talk about both of those next week. Okay. All right, when we get there. Anybody have any questions? Okay, you can get to the book here. And anybody on the coast have any questions down there? So it's working for you guys? Okay, great. I'm going to go ahead and I don't know where, there it is. I'm going to go ahead and stop.